Hello and welcome again to my Physics Online video lecture series. Today's video I'm going to be talking a bit about how to go about describing the motion of an object. Maybe a little bit about what motion is, or what we mean by motion in physics, and how we would describe it, but not in the strict sense of let's write a lot of equations about motion. That'll come later. In some sense, this is like an overview for this topic. So we will be discussing that a little bit today, and then there will be some follow-up videos in future days that discuss the actual description of motion. All right, so let's get into all of that. The first thing to note is, or to discuss, is what we mean by motion in physics. Now, motion in general basically means change, in a sense. An item can move from being short to being tall, for example. It can move from being a red color to being a blue color, that kind of thing. It's basically a change largely in some sort of external properties of the object or item or being. And so if you go and read like Aristotle or Aquinas, something like this, they'll talk about motion, but they may not just mean what we mean in the physics sense by motion, not in the modern physics sense. So what do we mean in modern physics? Basically, we mean that one of two things is changing. We either mean change in position, so an object, is maybe like right here at one location, and it moves to another location. So we move from here to here. It can also mean sort of like a change in orientation. And so that basically would be orientation. Maybe I have a triangle like this, that's a right triangle, and I spin it about so that instead of looking like this, it now looks like this. So I've spun it about some axis. Okay. Has the position of the triangle changed? Well, in this drawing that I've given, yes, but you could imagine like a piece of paper, for example. Let me find one that I can actually hold up. So I have a piece of paper here, and I spin it about like so. Has the position of this piece of paper changed? No, not really. It's still in the same basic position that it was when I started, plus or minus for like wobbling of my hand. But we've clearly changed the orientation. You have like the flat, dull cardboard face facing you here. You have the colored face with some pattern facing you here. There has been a change in motion here. That's what I mean by change in orientation. Now that change in orientation could be combined with a change in position. For example, I could rotate this thing around like this so that I have started off here in this orientation and I've ended up over here in this orientation. This drawing that I have of the two triangles, if you think of it as a rotation about this axis, is in fact a combination of those two things. Basically, this former one, change in position, is what's sometimes called translation or translational motion, and the change in orientation is more like a rotation or rotational motion. And ultimately, in a Physics 1 course, we kind of discuss both quantities or both types of motion. Usually we begin actually with the translational motion and then add rotational motion in stages later. Okay, I've defined what I mean by motion. Now, what about describing it? Well, we could describe this motion. I have an object starting at one location and then moving to another location. I could describe it as being a translation. I could describe a start and finish position, start and finish orientation, something like that. But that in and of itself doesn't give me a complete description. And I could also do things like talk about how did I go about moving it, and what, is it bent or straight or crooked or what have you as it moves. Those are all also kind of descriptions of what happens during the motion, but they're not really descriptions of the motion itself. Some of those things, in fact, we will talk about in future sessions of physics. How do I go about moving this or controlling its motion might, for example, be discussed in force and torque. But here we just want a description of the motion itself. So the term that is usually used when talking about describing an object's motion in physics is what's called kinematics. And we typically, when we are doing kinematics, care about a few different things that we could describe. And so in some sense there's via example is better than just via words, and I'll do it with the picture, and I'll draw the picture on the screen as well. Again, here's my little postcard or whatever. It starts here, it ends over here. So two of the things that might go into this description are where did it start and where did it end. So let's put those things in. Where did it start and end? We could also include where was it in between start and end. So where did it pass through? That would be everywhere that it's been between starting and ending. Okay, these terms right here, if we're just focusing on these things, we are considering terms that would be called position. So that's the actual where did it start and end, where did it pass through. Those are positions. We could be considering displacement. That is essentially the straight line distance from start to end, as well as what direction. And then we could also have distance traveled. That would be kind of akin to if I had an odometer on my postcard and I move it all around, the odometer is continually increasing how far the thing has traveled. So even if I start and end in the same location, as often happens with, say, your actual car, if you have a home, if you live at a house and you have a garage, let's say, you may park the car in the garage, and then at the start of the day you leave the garage, you go to work, you go to school, you pick up groceries, you go meet some friends, whatever you do with your day. Then at the end of the day, your car is back in the garage in the same spot that you left from. And so that means that your start and end location are the same, but you also know that you moved the car around that day. Okay. You also know that the odometer will have a higher reading. Okay, there's some other stuff that could go into it. You could say how much time did anything take? And on a related note, where at any time or any given time. Okay, so this collectively ends up being just like time, a parameter. We usually use a lowercase t for this, but I'm going to leave that off for now. And then you can combine this with this, right? If I start here and I end here, I start at this location, I end with this location. I know how far I've traveled, or at least I know what my displacement is. I may know how far I traveled if I know what route I took to get there. But if I also know how much time that took, then I get some additional information, right? If I very slowly move this from one location to the other so that it ends up over here somewhere, this is a very slow motion. I could also start from here and very quickly end up over here. That's relatively fast motion. It's fast enough that the camera kind of stutters a little bit in capturing it. Okay, so how fast did this change occur? What's the rate of change? What's the rate of displacement? What's the rate of distance traveling? Okay, so these things, how fast, what rate change, etc. These go into what are called velocity and speed. And in some sense you can get velocity and speed by combining position in time, displacement in time, distance traveled in time. Okay. So these are rate change of position. Now, just because you have a rate change of position doesn't mean that that rate change is constant. For example, I could have the thing slowly moving like this and then suddenly jump across the last distance. My rate change has itself changed. Could also have a smoother rate change in which the thing is slowly moving and then getting quicker and quicker and quicker and quicker and quicker and quicker. Okay, so there could be some sense of a rate change of a rate change. So let's call that rate change of velocity or speed. This is what's called acceleration. So some of what we're doing with kinematics here is linking these terms: acceleration, velocity, speed, time, position, displacement, distance traveled, all of that. And yes, there can be rate change of acceleration, that's called jerk. There's rate change of jerk, it's called jounce, and so on. But we'll stick to acceleration and then kind of like stop there in our typical descriptions. That's what we're basically building up to with kinematics. Now there's one other thing to discuss here, because kinematics at the end of the day, it's a type of model, and there are fundamentally two types of model. The first is the descriptive model. So kinematics basically falls into descriptive models. A descriptive model just kind of describes what's happening. A lot of kinematics is simply descriptive. There's a second type of model that we'll get to later, which is called explanatory. Explanatory models are usually things like the theories, Newton's force models, or Newton's force laws are theories that are built along explanatory models. They try to tell us why does something happen this way, not simply what has happened and what does it look like. So, we begin with descriptive, which is like kinematics. We eventually build to explanatory. And a lot of explanatory kind of falls into what we would call efficient and final causes philosophically. Why does this thing do this? Well, it's because it is trying to conserve energy, or it's trying to minimize time, or it has to respond to a force in this way. And so we for now are focusing on descriptive. We will begin with kinematics in the next few lectures. So thanks.